Hello everyone. So today we will see some questions related to the states of matter chapter. So let's start. Disclaimer slide which says the images used in our slide deck are for educational purposes only. We respect the intellectual property rights of the original creators and owners of these images. If you are the owner of any of the images used in this deck and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the images. Let's start. So, question number first. The intermolecular interaction that is dependent on the inverse cube of distance between the molecules is. Options are ion-ion interaction, ion dipole interaction, London force, and hydrogen bond. So you have 10 seconds to solve this question by yourself. After that, we will see the answer. Okay, so the correct answer is option D. How ion-ion interaction is dependent on the square of the distance. That is, ion-ion interaction will be inversely proportional to the r to the power 2. Similarly, ion dipole interaction is inversely proportional to r to the power 2 and London forces is inversely proportional to r to the power 6. And if we talk about the dipole-dipole interaction, that is hydrogen bonds, it will be inversely proportional to r to the power 3. Thus, hydrogen bond being dipole-dipole interactions is dependent on the inverse cube of distance between the molecules. Okay, so question number 2. A certain mass of oxygen gas occupies 7 liter volume under a pressure of 380 mmHg. The volume of same mass of the gas at standard pressure with temperature remaining constant shall be. Options are 26.60 liter, 54.28 liter, 3.5 liter and 7 liter. You have 10 seconds to solve this question by yourself. After that, we will see the answer. Okay, so the correct answer is option C. So at constant temperature, we know the Boyle's law, that is P1 will be equal to P2V2. P1V1 equal to P2V2. And standard pressure, P2 will be 1 atmosphere, that is 760 mf of Hg, because the pressure given in the question is also in this unit. So putting the values in the Boyle's law equation, we found V2 will be going to equal to 3.5 liter. Hence, option C is the correct answer. Moving to our question number 3. A bubble of gas released at the bottom of a lake increases to 8 times its original volume when it reaches the surface. Assuming that atmospheric pressure is equivalent to pressure exerted by a column of water 10 meter high, what is the depth of the lake? Options are 90 meter, 10 meter, 70 meter or 80 meter. You have 10 seconds to solve this question by yourself. After that, we will see the answer. Okay, so the correct answer is option C. By using Boyle's law, we can see that P1V1 will be equal to P2V2. So here P8V is equals to P1V. That is 8P will be equal to P1 because we get cancelled out. Here P is pressure below the water surface and P1 is pressure at the bottom. Therefore, pressure of water at the bottom will be equal to rho GH. That is the formula of pressure. Density G into H and pressure below water surface will be equal to rho G and H is 10 as given in the question. So P1 is coming out as 8 rho G into 10, that is 80 rho G. So P1 minus P is 80 rho G minus 10 rho G, that is 70 rho G. And in the 70 rho G, H is 70 meter. So the depth of the lake is 70 meter. Hence option C is the correct answer. Moving on to our next question, that is question number 4. Equal weights of ethane and hydrogen are mixed in an empty container at 25 degrees Celsius. The fraction of the total pressure exerted by hydrogen is. Options are 1:2, 1:1, 1:16, or 15:16. You have 10 seconds to solve this question. After that, we will see the answer. So, correct answer is option number D. How? So, moles of C2H6 will be given weight divided by the molar mass, that is 30, and moles of H2 will be given weight divided by molar mass, that is 2. So, mole fraction will be the mole of H2 divided by the total moles. It is coming out as 15/16. And mole fraction of H2 is equal to partial pressure of H2 divided by the total pressure. That is 15/16, as mole fraction is 15/16. Hence, option D is the correct answer. Moving on to the next question, that is question number 5. Through the two ends of a glass tube of length 200 centimeter, HCl gas and NH3 are allowed to enter. At what distance the white ring of ammonium chloride will first appear? The options are 81.1 centimeter from HCl end, 81.1 centimeter from NH3 end, 118.9 centimeter from HCl end, or the ring will not form. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option A. So let A centimeter from HCl and white fumes of NH4Cl are noticed. We suppose the answer first, that let A centimeter is the distance. So this is the vessel, this is the glass tube. Here HCl is entering, here NH3 is entering. Let's suppose at A distance, a point where the white fumes of NHCl are noticed is located. So this will be 200 minus A, because the total length is 200 centimeter. So from Gram's law, we know that RHCl upon R of NH3 will be equal to under root molar mass of NH3 upon molar mass of HCl. Or we can write it as A by T multiplied by T upon 200 minus A, that is the distance, will be equal to under root 17 divided by 36.5. Since time of diffusion in tube for both is same, both the gases diffusing at the same time, therefore from this equation A is coming out as 81.1 centimeter from the HCl, and hence the option A is the correct answer. Moving on to our next question, question number 6. At STP, 0.48 gram of O2 diffused through a porous partition in 1200 seconds. What volume of CO2 will diffuse in the same time and under the same conditions? Options are 286.6 milliliter, 346.7 milliliter, 112.2 milliliter, or 224.8 milliliter. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option A. So volume of O2 diffused will be 22,400 multiplied by 0.48 divided by the molar mass of oxygen O2, that is 32. It is coming out as 336 milliliter. Let the volume of CO2 diffused will be X milliliter. So rate of diffusion of O2 will be 336 divided by 1200 milliliter per second. Similarly, rate of CO2 will be X upon 1200 milliliter per second. So R of O2 upon R of CO2 will be V of O2 divided by T multiplied by V of CO2 divided by T, that is time. So which will be equal to molar mass of CO2 divided by molar mass of O2. And on putting the values of all the variables, we calculated the X value, that is 286.6 milliliter. So option A is the correct answer. Moving on to the question number 7. What are the relative rates of diffusion for this and this molecule? Options are 1.0043, 2.540, 1.503 and 1.119. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the solution is according to Graham's law of diffusion, R1 by R2 is equals to under root M2 by M1, we know. So on putting the molecules in the formula and their molar mass, the ratio is coming out as 1.0043. So the option A is the correct answer for this question. Moving on to the next question, question number 8. Assuming the same pressure in each case, what is the mass of hydrogen required to inflate a balloon to a certain volume V at 100 degrees Celsius? If 3.5 gram helium is required to inflate the balloon to half the volume V at 25 degrees Celsius. Options are 3.8 gram, 2.8 gram, 4.2 gram or 4 gram. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so correct answer is the option B. So for hydrogen molecule, P cross V will be equal to nRT, and for helium, same P cross V will be nRT. Hence, we can find out the weight of H2 here, which is coming out as 2.8 gram. So the option B is the correct answer. Moving on to our question number 9. Helium atom is 2 times heavier than the hydrogen molecule at 298 Kelvin. The average kinetic energy of helium is. Options are 2 times that of hydrogen molecule, same as that of hydrogen molecule, 4 times that of hydrogen molecule, and half that of hydrogen molecule. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct option is B option. The average kinetic energy depends only on temperature and does not depend upon the nature of the gases. That's why it does not depend on the nature of gas, and hence option B is the correct answer. Moving on to our next question, question number 10. For a monoatomic gas, kinetic energy is equals to E. The relation with RMS velocity is. Options are U will be equal to under root 2E upon M. U will be equal to under root 3E upon 2M. U will be equal to E upon 2M under root, and U will be equal to under root E by 3M. You have 10 seconds to solve this question by yourself. After that, we will see the answer. Okay, so the correct option will be the option A. How? So U of RMS, we know that under root 3 PV by M, and PV is equals to NKT, where K is a Boltzmann constant. So for a molecule, N will be equal to 1, PV will be equal to KT. So URMS will be equal to under root 3 KT by M. So kinetic energy will be equal to 3 by 2 KT, or KT, or it will be equal to 2 by 3 E. Okay, so URMS will be equal to under root 3 multiplied by 2 by 3 E divided by molar mass, and it is 3 by 3 will cancel out 3, and it is coming out as under root 2 E by M. So we rearrange here the equation. Okay, so left hand side, right hand side, we write the we take this 3 by 2 here in the left hand side, and KT will become 2 by 3E. That's why the velocity we get for RMS velocity will be coming out in E terms like this here. So the answer will be under root 2E by M, and hence the option A is the correct answer. Okay, moving on to our next question. Question number 11. At what temperature the RMS velocity of SO2 be same as that of O2 at 303 Kelvin? Options are 273 Kelvin, 606 Kelvin, 303 Kelvin, and 403 Kelvin. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option number B. So the ratio of U RMS velocity of SO2 to O2 will be equal to under root temperature of SO2 multiplied by molar mass of SO2 and multiplied by molar mass of O2 and temperature of O2. So this fraction is 1, which will be equal to under root these terms, and we just put the terms here which is given in the question and which we know. So T of SO2 will be coming out as 606 Kelvin, and that's why the option B is the correct answer. Okay, so moving on to our next question, question number 12. The ratio between the root mean square velocity of hydrogen molecule at 50 Kelvin and that of oxygen molecule at 800 Kelvin is. Options are 4, 2, 1 or 1 by 4. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option number C. So URMS we know that will be equal to under root 3 RT by M. So U1 by U2 will be equal to under root 3 RT1 by M1 multiplied by M2 upon 3 RT2. So by putting the values in this equation, we find out that the ratio between the U1 and U2 will be coming out as 1 for the molecule of H2 and O2. Right? So option C is the correct answer. Moving on to the next question, question number 30. As the temperature is raised from 20 degrees Celsius to 40 degrees Celsius, the average kinetic energy of neon atoms changes by a factor of which of the following? Options are 1 by 2, under root 313 upon 293, 313 upon 293 or 2. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so option C is the correct answer, and the solution will be kinetic energy. We know that will be equal to 3 by 2 RT. So kinetic energy is directly proportional to T, as we can see by this formula. So 20 degrees Celsius is changing to 40 degrees Celsius, and using the formula, kinetic energy will be equal to 3 by 2 RT. And when we calculate the ratio for these two temperatures, so K of 40 degrees Celsius upon K of 20 degrees Celsius will be equal to T at 40 degrees Celsius upon T of 20 degrees Celsius, because kinetic energy is directly proportional to the temperature, right? So on putting the value of T at 40 and T at 20, we are getting the ratio of K as 313 divided by 293. Hence, option C is the correct answer. Moving on to the next question, question number 14. To an evacuated vessel with a movable piston under external pressure of 1 atmosphere, 0.1 mole of helium and 0.1 mole of an unknown compound, which pressure where vapor pressure 0.68 atmosphere at 0 degrees Celsius are introduced. Considering the ideal gas behavior, the total volume of the gases at 0 degrees Celsius is close to. Options are 3, 5, 7 or 9. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer will be option C. Since the external pressure is 1 atmosphere, the gas pressure is also 1 atmosphere, as piston is movable. So out of this 1 atmosphere, partial pressure due to known compound is 0.68 atmosphere. Therefore, partial pressure of helium will be 1 minus 0.68, that is 0.32 atmosphere. So volume will be nRT upon P. So moles of helium, RT is given, and upon P of helium. So putting the values, the volume is coming out as 7 liter. Hence, the option C is correct answer. Moving on to the question number 15. If 10 to the power minus 4 decimeter cubic of water is introduced into a 1 decimeter cubic flask at 300 Kelvin, how many moles of water are in the vapor phase when equilibrium is established? We have given the vapor pressure of water molecule at 300 Kelvin and the R value. So options are 5.56 into 10 to the power minus 3 mole, 1.53 into 10 to the power minus 2 mole, 4.46 into 10 to the power minus 2 mole, and 1.27 into 10 to the power minus 3 mole. You have 10 seconds to solve this question. After that, we will see the answer. Moving on to the answer, which is option number D. So N, we know that will be equal to PV by RT. On putting the values, we are getting N is 1.27 multiplied by 10 to the power minus 3 moles. Hence option D is the correct answer. Moving on to the question number 16. The compressibility factor, that is Z, for a real gas at high pressure is. Options are 1 plus RT upon PB, 1 plus PB upon RT, or 1 minus PB upon RT. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the option C is the correct answer. And van der Waals equation for 1 mole of real gas is P plus A by V square multiplied by V minus B will be equal to RT. So when pressure is high, as given in the question, P is really greater than A by V square. So we can neglect the A by V square as compared to P. So P plus A by V square will become P only. Thus, the equation will become P V minus B equals to RT. On multiplying the P in the bracket, we get PV will be equal to RT plus PB. And we know that compressibility factor Z is equals to PV upon RT. So dividing this equation by RT, we get Z will be equal to 1 plus PV by RT. Hence, option C is the correct answer. Moving on to question number 17. The compressibility of a gas is less than unity at STP. Therefore, options are Vm is greater than 22.4 liter, Vm less than 22.4 liter, Vm equal to 22.4 liter, or Vm equal to 44.8 liter. You have 10 seconds to solve this question by yourself. After that, we will see the answer. Okay, so the correct answer is option number B. So Z is equals to PV by nRT. That is, PV by nRT is less than 1, or PV will be less than nRT, because P is 1 atmosphere at standard temperature and pressure. So V will be less than 0.0821 into 273, or V will be less than 22.4 liter. Hence, the option B is the correct answer. Moving on to next question, that is question number 18. If Z is a compressibility factor, van der Waals equation at low pressure can be written as. Options are Z will be equal to 1 plus RT upon PB, 1 minus A upon VRT, 1 minus PB upon RT, or 1 plus PB upon RT. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option number B. To solve this problem, the stepwise approach is required. So the van der Waals equation, then apply the condition that at low pressure, volume becomes high. That is, V minus B will be equal to V, because V will dominate here and B will be neglected. Now calculate the value of compressibility factor Z, and Z equals to PV by RT. So according to van der Waals equation, P plus A by V square multiplied by V minus B will be equal to RT. So at low pressure, this equation will become this, P will be neglected here, and PV, on multiplying V inside the bracket, we get PV plus A by V equals to RT, or PV equals to RT minus A by V. And dividing both sides by RT, we get PV by RT will be equal to 1 minus A upon RTV. Question number 19. In van der Waals equation of state for a known ideal gas, the term that accounts for intermolecular forces is. Options are V minus B, RT inverse, P plus A by V square, or RT. You have 10 seconds to solve this question. After that, we will see the answer. Okay. So, correct answer is option number C. The van der Waals equation for state of 1 mole of known ideal gas is denoted by the equation this. P plus A by V square multiplied by V minus V will be equal to RT. So, the factor P plus A by V square is accountable for the intermolecular force, whereas the term V minus V is accountable to the molecular volume. Hence, option C is the correct answer. Moving on to the question number 20. For 1 mole of van der Waals gas, when B equals to 0 and T equals to 300 Kelvin, the PV versus 1 by V plot is shown below. You can see here. The value of van der Waals constant A is, we have to find out the A. Options are 1, 4.5, 1.5 and 3. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is answer number C. So P plus A by V square multiplied by V will be equal to RT here, and PV will be equal to RT minus A by V. This is, consider this as a first equation. Now equation first is a straight line equation where the slope is minus A, and equating with slope of the straight line given in the graph, minus A will be equal to, the maths formula x2 y2 minus y1 upon x2 minus x1. By doing this formula and putting the values, we get A will be equal to 1.5. Hence, the option C is the correct answer.